Today we're going to do function operations. So your essential question is, how do I know what the domain of a function is? So if we take a look at this slide, it shows that operations with functions are addition, subtraction, multiplication, and division. Now these over here under the definition are just what this will look like in your textbook or in example problems that we'll do. So h of x is the answer when I take the function of f of x and the function of g of x and I put them together. So these will all be separate functions, and then your answer will also be a function. So what we're going to do is we're going to add two functions together, subtract two functions, multiply, and divide. So we're just going to jump into some examples here. So for example, if we have f of x equals 5x and g of x equals x plus 2, we're going to find what f of x plus g of x is, and they also want us to state the domain of each answer that we come up with. So basically we're just using substitution here. We're plugging in 5x for f of x, and we're plugging in x plus 2 for g of x. Now I always put these in parentheses because especially when you're subtracting, it will make a difference in your answer. So from here I can combine like terms. So 5x plus x will be 6x, and then plus 2. So this will be my answer. Now we're going to state the domain. So the domain, if you guys remember when we did functions, the domain is associated with the x value. So the domain is what you can plug in for x and get a real answer. So it can't be undefined and it can't be imaginary. So if I look at the original functions, you have to look at the originals and the answer. If I look at the original function, 5 times x, I can plug in any number I want for x and I will get an answer. It doesn't matter if it's negative or positive or a decimal, I will get an answer. Same with g of x. If I plug in any number I want for x, it will come out with a real answer. And then if I look at the answer, 6x plus 2, then I can plug in any number I want for x and I will get a real answer. So the domain of this function would be all real numbers, and the symbol for that is kind of like an R with double posts. Now we have something called interval notation, which shows like the interval of numbers that you can plug in for x, and so we could plug in any number from negative infinity to positive infinity. So this is how you would write the answer in interval notation. So you could put either answer for that and I would accept it. Alright, now let's try subtracting. So we have f of x, which is 5x, minus g of x, which is x plus 2. So if I subtract these, 5x minus x would be 4x, and then I don't have anything that I can put with the 2, so this would be like I take 0 minus 2, which would be negative 2. So because the 2 is behind the negative sign, it's going to be a negative 2. So this will be our answer. And if I already discussed the domain of the originals would be all real numbers, and the domain of this answer would be all real numbers as well, because I can plug in any number I want for x and I can get an answer that's a real answer. So the domain of this one would be all real numbers, or you could put from negative infinity to positive infinity if you wanted to write it in interval notation. So let's try some multiplying. So now I have 5x times x plus 2. So now when I'm doing this, I'm going to distribute because I'm multiplying them together. So 5x times x would be 5x squared, and 5x times 2 would be 10x. So my answer is 5x squared plus 10x. And I already know the domains of the originals is all real numbers. If I look at this one, same thing. I can plug in any number I want for x, and I will get an answer. So the domain of this one, again, is all real numbers, or from negative infinity to positive infinity. We'll get to some examples where they are different in a minute. So If you're not quite understanding that yet, it'll be okay. Now for this one, we're dividing. So I would have 5x divided by x plus 2. Now I can't simplify this, so this is just my answer. So a lot of times when you're dividing, sometimes depending on what the functions are, you'll just have your answer written as a fraction. So that's it. Now for this one, I know the domain of the original functions are both all real numbers, and I can plug in anything I want on the top for x, but because this is a fraction, I have to pay attention to the bottom, because when we have fractions, you can't divide by 0. So if this bottom part is equal to 0, then I'm in trouble because it would be undefined. So I have to figure out what would I plug in for x to make the denominator equal 0. So if I set x plus 2 equal to 0, then I could subtract 2 from both sides, so x equals negative 2. So if I plug in negative 2 for x, then my denominator will equal 0, and I'm going to get an answer that's undefined. So basically, I can plug in any number except negative 2. So how we're going to write this for the domain is we are going to write that I can plug any number from negative infinity to negative 2, but I can't plug in negative 2, it's not included. So to write that, I'm going to write from negative infinity to negative 2, and I'm going to put a parenthesis around the negative 2. The parentheses means that it's not included as a solution. Now, if I did a bracket, that would mean that it was included, and we'll do an example of that later. And then I can plug any number above negative 2. So I would write the union symbol, which is kind of like and. So and, I can plug in any number from negative 2 to positive infinity. So this shows that negative 2 is not included as an answer because it has parentheses around them. And so I can plug in any number from negative infinity to negative 2, but I can't plug in negative 2. And I can plug in any number from negative 2 to positive infinity. Okay? So that's how you would write that in interval notation. All right, let's try a few more examples. So let's try adding and subtracting functions that have rational exponents. So these have exponents that are fractions. Okay, so now if I do f of x plus g of x, I have 4x to the 1/2 plus negative 9x to the 1/2. So I'm combining like terms. Now these are considered like terms because they have the same variable and the same exponent. So 4 plus negative 9 would be negative 5x to the 1/2. So that's my answer. Now let's talk about the domain. So if I look at the original functions, they're both raised to the 1/2 power. Now, if you remember from the first section we did, raising something to the 1/2 power is the same as what in radical notation? Okay, 1/2 power is just like taking the square root of something. So, there are certain numbers that I cannot take the square root of because I will get an answer that is imaginary. So, I cannot plug in any negative numbers for x because if I do, I will get an imaginary answer. I can plug in 0 because the square root of 0 is just 0, and I can plug in positive numbers, but not negative numbers. So my domain of these two would be anything above 0. And if I look at my answer, it's also raised to the 1/2 power, so it has the same domain. So my domain is going to be from negative infinity, I'm sorry, that's wrong. Let me erase here. I have to plug in any number that is 0 or greater. So 0 is included, so I'm going to put a bracket around it because that means that I can plug in 0 all the way up to infinity. So I can plug in 0 to infinity, but not anything less than 0. So that would be my domain. So now let's talk about f of x minus g of x. So now I'm going to take 4x to the 1/2 minus negative 9x to the 1/2. So since I have minus and negative, I'm going to be really adding. So this would be 13x to the 1/2 as my answer. Now for the domain, we already know that I can't plug anything negative, and this has a 1/2 power also, so I can't plug in any negative numbers. So this one will have the same domain, anything from 0 to infinity, and 0 is included, so it has a bracket around it. Alright, let's try some more multiplying and dividing. So this time we've got some new examples. F of x equals 6x, and g of x equals x to the 3/4 power. So we're multiplying, so we're going to take 6x times x to the 3/4 power. Now when I'm multiplying, what do I do with the exponents? So I would have 6 in the front, because that's my coefficient, and then this is like x to the first, so I have 1 plus 3/4. I could change 1 to 4/4, so 4/4 plus 3/4 is 7/4. So really I get 6x to the 7/4 power, and that would be my answer. Okay, now if I look at the domain of my original functions, for 6x, I can plug in any number I want for x because there's no roots or like denominators, so I can plug in anything I want and get a real answer. For g of x, this would be like the same as the 4th root of x to the 3rd power if I rewrote that in radical notation. So I'm taking the 4th root of this number. So since my root is even, I cannot plug in any negative numbers for x, because if I do, then I'll get an imaginary answer. So if I look at my answer here, it also has a 4th root, so I can't plug in any negative numbers for my x. So my domain for this one is also going to be from 0 to positive infinity. 0 can be plugged in, because I can take the 4th root of 0, it's just 0. And I can plug in anything positive all the way up to infinity. Okay, last example, f of x divided by g of x. So this time I have 6x divided by x to the 3/4. So when I'm dividing, what do I need to do with my exponents? I subtract. So again, this would be like a 1, which is the same as 4/4. So 4/4 minus 3/4 would be 1/4. So I end up with 6x to the 1/4 power as my answer, because I just subtracted the exponents and the 6 stays on top. So again, this has a 4th root, so my domain is going to be anything from 0 to infinity. And that would be the answer. So you guys just need to go back to the essential question and write your summary, and we will be finished.